Okay, A we did because it was on the note sheet that we looked at together, and we determined it was 6n plus 5. If you have it in a vertical table like this and you realize it's adding 6 each time, that gives you the variable term, and then you have to figure out the constant term by testing like we practiced. Here I start out at 17, but then I have 5, so that's minus 12. And if I subtract 12 from 5, I get minus 7. So it looks like that subtracting 12 each time works. So instead of having 12n, now I have negative 12n. Because remember, subtracting 12 is the same as adding negative 12. And so I have negative 12n, but then when I test it for n equals 1, that would give me negative 12 multiplied by 1 is negative 12. But I need it to be 17. I would need to add 12 just to get to 0. So I need to add 12 and then 17 more, so plus 29 for this one. Negative 12n plus 29. Now, sometimes students have a different way of writing these rules, and here's something that I'm just going to throw in here in case you're doing it this way so you know it's equivalent. If you start out with the first term and then you add the common difference multiplied by n minus 1, that will also give you the correct terms, because when n is 1, n minus 1 would be 0, and so we would just have 17. But when n is 2, we would have 2 minus 1 is 1, 1 times negative 12 is negative 12, and 17 plus negative 12 is positive 5. And so that's taking the common difference, multiplying it by n minus 1, and then adding the first term. It's another way. It's equivalent to this expression. If we distributed the negative 12, you would see that. C, we're adding 3 each time. So 3n. But if n was 1, that would be 3. But I have negative 4, so I need to subtract 7 to make it work. Maybe I'm going too fast. If I have 3n, I know it's 3n because the common difference is 3. When n equals 1, 3 multiplied by 1 would be 3. But I need it to be negative 4. I would need to subtract 3 just to get to the 0. Then I need to subtract 4 more. So altogether I'm subtracting 7. So 3n minus 7, or 3n plus negative 7. If you try that with another value of n, you'll see that it works. If I use the alternative solution that I showed you in the last one, 3 times n minus 1, and then you start out with negative. So negative 4 plus 3 times n minus 1 is equivalent also. D, we're adding 15 each time. So the rule starts out with 15n. When n is 1, 15n would be 15 times 1, which is 15. But I need it to be, when n equals 1, I need the term to be negative 37. If I subtracted 15, I would be at 0. I would need to subtract another 37, so altogether I need to subtract 52, I think. I'll know for sure in a minute because I'm going to test it with another value of n. 15n minus 52. Let's try when n is 4. So 15 times 4 minus 52. 15 quadrupled is 60. And 60 minus 52 is 8. And 8 is what I was hoping I would get. And so I feel confident that that's the correct rule for E. F, we're subtracting 2 each time. So the common difference is negative 2. So we start out with negative 2n. And when n equals 1, that would be negative 2 times 1, or negative 2. But I need it, when n is 1, I need it to be 5. So I need to add 2 and then 5 more to get to 5. So I need to add 7. So I think the rule is negative 2n plus 7. I'm going to test it with n equals 3. Negative 2 times 3 plus 7 would be negative 6 plus 7, and that is positive 1. So that's the right rule for that arithmetic sequence. G, I'm going down by 1 each time. Minus 1, minus 1. So negative 1n. When n is 1, that would be negative 1 times 1, which is negative 1. But I need it to be positive 10, so I need to add 11. Negative 1n plus 11. Also, we probably wouldn't write negative 1n because negative 1n is just negative n plus 11. It wouldn't be wrong if you wrote negative 1n, but we know 1n is n, that's the multiplicative identity. And so it's just negative n plus 11. And that one's easy to test because if n was 4, the opposite of 4 is negative 4. You add 11 to negative 4, you do get positive 7. J is increasing by 6 each time. So the rule starts out with positive 6n. When n is 1, we would have 6 times 1 is 6. But I want negative 15, so I need to subtract 6 just to get to 0. And then I need to subtract 15 more to get to negative 15. So altogether I'm subtracting 21. 6n minus 21 is the rule, I think, but I'm going to check it with another value of n, like 4. 6 times 4 is 24. 24 minus 21 is 3, and that's what I hoped it would be. I think I can see the value in learning the other method if you're interested in learning it. All the stuff I do about when I have 6, I would have to subtract 5 and then subtract 15 more. You can avoid all that if you just understand that you can start with the first term, add the common difference, so plus 6, and multiply that common difference by n minus 1. And that's an equivalent rule that will work. Okay. Well, there's a lot of these. K, we're adding 1 each time. And so 1n, or just n, but when n is 1, that would just be 1. But I need to be negative 6, so I need to subtract 7. So 1 minus 7 would be negative 6. So n minus 7 is the rule for k. For m, we're subtracting 5 each time. And so negative 5n would start the rule. When n is 1, that would be negative 5 times 1, or negative 5. But I need it to be negative 12, so I need to subtract 7 more. Negative 5n minus 7. N is plus 3. The common difference is plus 3. So 3n, but I would need to subtract 4 to make the rule work, because 3 times 1 is 3, but I want negative 1. So 3n minus 4 for n. Oh, is this one of the first ones that, nope. Minus 9. So negative 9n. But if n is 1, that would be negative 9 times 1, or negative 9. I need positive 3 when n is 1. So I need to add 9 and then 3 more, so I need to add 12. So negative 9n plus 12 is the rule. Q minus 2 each time. So negative 2n, but when n is 1, that would be negative 2 times 1, negative 2, but I want it to be positive 1. So I need to add 3 to make that positive 1. So negative 2n plus 3 for Q.